One of the last aspects of particles we're going to look at is the particle world collider. This allows you to take your particles and make them collide with the geometry of your surrounding environment. Now currently we have a particle system that is doing pretty much what it's been doing for most of these videos, just kind of blowing off into one direction, kind of like a stream of fire. But what I'm going to do is change this around a little bit. So let's take our min and max size and I'll kick that up to make the particles a little bit bigger. Let's take our emission and I'll pull this down. Let's say we emit only 1 particle per second. And our energy, let's set this to 3 by 3. So they're all living for about 3 seconds. And if I scroll down to my particle renderer and take a look underneath the shader, we got a few other things I want to change here. First off, let's go. Actually, I don't want to select the texture. I want to change the actual shader. So instead of using particles additive soft, let's go under particles. And let's just drop in a regular additive. Now this allows us to change the tint color of our particles. So I'll make this white so that we're not kind of tinting them down toward gray. I want these to be very bright. And we'll take the alpha and push this all the way up to full bright. So these particles stay nice and big. Now all I need is some way to pull these particles down, so a force seems to be in order. So let's grab force Y and set it to say -3, and that'll make the particles start to fall. And as you can see, they're falling into the floor, and in fact, they're falling down through the floor if we get down here. Now, what I want to have happen is for these particles to actually impact with the floor itself, and doing this is very easy, but I need to make sure I actually have the particle system selected and not this game object to which the particle system is parented. Then I'm going to come under Component, jump down to Particles, and grab the Particle World Collider. As soon as I do that, we start getting collisions right away. Now, as with all things, this is a bit of a performance hit because now we have to check for collisions, which we didn't have to check for a little while ago. But, you know, if you absolutely have to have your particles hitting a surface, this is what you got to do.
Right. If you were to do a scene, something like rain, where you had thousands and thousands of raindrops, you wouldn't want to do this effect to make sure that every raindrop hits the ground and bounces. So what you could do is stack your systems in such a way where you had a lot of particles that didn't have a collider that passed through, but you had another particle system that had fewer particles, and only those few particles were actually bouncing, giving the illusion that something is actually hitting the ground.
You know, not to try to make an analogy with guns, but for some reason it just came to mind. It's kind of like how they set up tracer fire in high-rate machine guns. Only like every 4th round actually has a tracer in it, but it still looks pretty steady. You don't really notice the difference. Okay, I know, it's totally random. Now, moving on from here, if we scroll down, we actually have a World Particle Collider. It's not Particle World Collider. I think that's what I said in the beginning of the video. It's the World Particle Collider, if I get that straight. Now, it only has a few properties, and they're all pretty easy. The first is our bounce factor. This is how bouncy the particles will be when they hit stuff. So if we set this to 1, they're going to leave the ground with just as much velocity as they had when they hit. So, but setting this back to its default of 0.5 means we're losing half of that velocity on every single impact. Collision energy loss. Again, I have to keep reminding myself that energy translates to lifespan, because at first when I first saw this ever, immediately I thought that's how much motion we're losing. But of course, energy is lifespan. So this is how much life is lost on each collision. If this is in seconds, so if we set this to 1, each particle is losing a second of its life on each collision. You'll now notice that we're not getting any second bounces because we're shortening that lifespan way too much. Now let's go ahead and set that back down to 0. Next, collides with. This allows you to select a particular layer for collision. Of course, this will be more useful as you start to establish more layers in your scene. So if you wanted to, you could have a layer called particle collision, and that's the only layer that you actually collided with. Any layers that are unchecked here, you simply won't collide with. So if you don't want the particles to collide with water surfaces in your level, just make sure that you uncheck water, and that will solve the problem. Of course, that would be really important if you had something like rain or snow or anything that you don't necessarily want to see bouncing off the surface of water. Then that's how you could do that. Now, moving down from here, we have send collision message. This won't do anything for you as is. All this does is give you a way that you can tie into your particle system with script and receive the information that a collision has taken place.
Right. This type of system doesn't have the ability to spawn off another set of particles like some more advanced systems would have.
Right.
So this is a way that you could script it so as your raindrop hits the ground, you get a little splash.
You could fire off a second one-shot particle system that fired off little tiny splash particles. Or all kinds of different things.
Mm-hmm.
Cluster bomb kind of
Exactly.
effect. Now, let's go ahead and turn that back off. Finally, we have min kill velocity. And basically, if after a particle bounces, it drops below this velocity, it's going to simply die off. So if we leave this at 0, that means we're never actually achieving this low velocity. If we really start to crank this, like we set it to 1, as soon as the particles drop below that velocity, they die. If we set this really high, like to 5, they start dying off a lot sooner. As a matter of fact, in the case of 5, since they don't actually leave the ground greater than that, they die right on impact. Technically, I think they die shortly thereafter, but it's so quick we can't even tell the difference. So we can set that to 2, and now they're dying on that second impact. So if we take their bounce factor and we start to really pull that down to say like 0.2, then we have to pull our min kill velocity down. You'll see it's kind of a balancing act. There you go. Now let's try maybe 0.5. There you go. And so now they're hitting that second bounce and they're dying. So again, that's just a way to make a particle stop moving. I'm sorry, to make it die off as it slows down to underneath this minimum velocity. So that is our World Particle Collider, and that is going to wrap everything up for this video. Thank you very much for watching.